So today we're going to talk about section 6.4, which covers the rhombus, the rectangle, and the square, all of which are just special parallelograms. So all of these are parallelograms, which means that all of the properties of parallelograms apply to them as well. So if we talk about a rhombus is just a parallelogram with all four congruent sides. Okay, but that's the definition of a rhombus, but all of the properties of a parallelogram still apply. So opposite sides are still congruent, opposite angles are congruent, opposite sides are parallel, consecutive angles are supplementary, and diagonals still do bisect each other. One other property that I want to add to that is that the diagonals are perpendicular. And one more property about the diagonals is that the diagonals bisect opposite angles. So if we draw a picture of a rhombus, it looks like a parallelogram, but we know that all four sides are going to be congruent. When we say that the diagonals are perpendicular, remember that the diagonals cut across the figure and connect vertices. Perpendicular means that they intersect at a 90-degree angle. And if they bisect opposite angles, then that means that it cuts the angles in half to make two congruent angles. I'm not going to mark all of the other properties of the parallelogram, but again, once more, all of those properties still apply to the rhombus. Okay, so next up is the rectangle. And the rectangle is just a parallelogram with four right angles. So we can draw a parallelogram with four right angles. And one property that is special to the rectangle is that the diagonals are congruent. So if we draw in our diagonals, they're going to be congruent to each other, and they also bisect each other. So what actually happens is that all four of these pieces end up being congruent to each other. Once more, all of the properties of the parallelogram apply to the rectangle as well. Now a square is just a special type of parallelogram. It is also a rectangle. It is also a rhombus, but a square is just a parallelogram with all four congruent sides and all four right angles. So if we draw a picture of that, it has to have four congruent sides and four right angles. All of the properties of a parallelogram still apply, but since it's a rhombus, all of the properties of a rhombus apply as well. So the diagonals are perpendicular. The diagonals bisect opposite angles, and the diagonals are congruent. So what actually ends up happening, if you draw your diagonals in here, all four pieces here are congruent because the diagonals cut each other in half and have the same length, so you end up getting four equal pieces there. And when you bisect the 90-degree angles, you actually get 45-degree angles in here. And that happens every single time on a square. This is the most special figure that we're going to talk about. Okay, so let's put some of those properties to use. In example 1, it says, in the diagram, ABCD is a rectangle. Find AD and AB. Okay, because it's a rectangle, we can mark a few things. We know that these are all right angles. And because it's a rectangle, it means that it is also a parallelogram. So opposite sides are congruent. So if BC is 5 AD is 5. If DC is 8, AB is also 8. So after I label my figure, I will go ahead and answer all of the things that they're asking me for. So find AD, we did that already. AD is 5. We found AB already. That's 8. And the measure of angle A, B, and C and D are all 90. So the measure of angle A equals the measure of angle B equals the measure of angle C equals the measure of angle D. They're all equal to 90. You could write those all separately, or you can combine them like that. Example 2. ABCD is a rhombus. Again, that means it is also a parallelogram. So all of those properties apply as well. But for a rhombus, we know a few things. All 4 sides are congruent. We know that the diagonals are perpendicular, so they create 90-degree angles. And what ends up happening is we have a triangle in here that has an angle that measures x that they want us to find. But like we just said, this angle in here is 90 degrees. So in that triangle, we have a 60-degree angle, a 90-degree angle, and an angle that measures x. So all we have to do is say 180 minus 90 minus 60, and we find that x is 30 degrees. If you wanted to set it up like 60 plus 90 plus x equals 180, you could do that as well and just solve for x. Example number 3. Classify the figure as specifically as possible and explain. Okay, so first of all, the most general is a quadrilateral. Well, we know that it's a polygon, I should say. Okay, we know it's a quadrilateral because it has 4 sides. We know that it's a parallelogram because opposite angles are congruent. But we more specifically know that it is a rectangle because we have all 4 right angles. So the question is it a square? Is it a rhombus? The answer is no, because all 4 sides are not congruent. So the most specific classification for this polygon is a rectangle. Your explanation is that all 4 angles are right. So at this point, you are just responsible for the checkpoints 1, 2, 3, 4, 5, 6, 7.